I'll go over this one over here since it's not in your textbook. So we have a standard base solution, and we have 25 mils of H2SO4. We don't know its concentration. So this here is going to be our titrand, or our analyte. Titrand or analyte, we don't know its concentration. We want to figure out what the concentration is. And so I'm going to start off by writing just a balanced equation. NaOH, AQ, plus H2SO4, AQ, and then we'll produce some water, and some salt. Na2, SO4, AQ. And we're just going to put down that we're looking for the concentration. We have the volume given to us. It's 25.0 milliliters. And we're going to convert that into liters. 0.0250 liters. And since we're looking for concentration, we know that our concentration is going to be C is equal to N over V. So what we need, we already have V, we need N. We don't have N right now, but we can figure N out based on the amount of base that was required to do this titration, to reach the end point. So what do we know about our base? Well, we know that the concentration of our base is 0.1000 molar. And we know the volume of our base that we used, and so we can see that from our table over here. Now, typically you would have to figure out the volume of NaOH used, but I'm just going to show you what happened. So these are the trials that we did. In trial 1, our initial reading was 0.00 milliliters, and our final reading was 10.62. So to find the volume used, I simply did final minus initial, and that gave me 10.62 milliliters. In my second trial, my initial reading of the base was 10.62 mils. My final reading was 21.44 mils. And I did that final minus initial, I got 10.82. And then lastly, for my third trial, I had 21.44 mils to start off in my burette. That's what I was at in terms of the volume that I read. My final reading was 32.04 as I went down, and I did that subtraction, I got 10.60 milliliters. And so just to show you what that would look like, I'm just going to draw one of the trials out. Here's my burette, poorly drawn. You want to start sketching these to make sure you understand what you're doing. Here's my volumetric flask, or sorry, not volumetric flask, my Erlenmeyer flask with my acid in it. There's 25.0 mils of H2SO4, and there's probably some indicator in there, maybe some phenolphthalein. In here, let's say I was doing trial 2. Let's say I was, and this is, I'm going to have my burette a little bit longer. This would be my 10.62. And then I keep adding the base until my level gets to this, which would be my 21.44, and that's in milliliters. Then I calculate this difference, that difference is the amount I use is my 10.82. And so essentially you did this 3 times. So notice that you don't always refill your burette after every trial. In this scenario, I was able to put it up to the 0. You don't have to start at the 0 line. You could start lower if you want to. I mean, if you go to the 0 line, you run the risk of spilling. But anyways, this student here started the 0 line, went to 10.62, and that was when it ended. Then we got a new batch of acid and started from the 10.62 line, and then it ended at 21.44. Then we got a new batch of acid when that was done, and we started at 21.44 line and went all the way down to the 32.04 line. And that ended our titration. And so we knew our titration was over when the color changed and we reached our endpoint. But right now we're wondering, well, which volume of base do we use? Well, we use the average. So you simply add them all up. So 10.62 plus 10.82 plus 10.60, and you divide that by 3. And when you do that, you get an average, and your average is 10.68 milliliters. Or, if you wanted it in liters, you would divide that by 1,000, and you get 0.01068 liters. And that is what our volume is going to be for the NaOH. 0.01068 liters. So we have everything we need now. This is a basic stoichiometry problem now. The only thing we had to do was find the data. The only difference that you're really seeing here is you have to go out and do the work yourself. You're not given all the information. You're not given the information about the amount of base that's used. You need to go figure it out. But then after that, once you have it, it's a basic stoichiometry problem. There is one thing I think I'm forgetting to do, and that would be to balance the equation. So I should put a 2 over here. I need 2 NaOHs. And then I think now it's balanced. No, I should put a 2 over here as well. And now it's balanced. So now that it's balanced, now I can do my stoichiometry problem to find my concentration of acid. So I'm going to do the calculations just down the right corner here. So first I'm going to find my number of moles of base used. So N of base is going to be equal to our C times V, which is going to be our 0.1000 moles per liter times our 0.01068 liters. Cross liters out, and you get 0.00168 moles. Our next step is to do our mole ratio to find how many moles of H2SO4 must have been in there. So we know it's a 2-to-1 ratio, which means we're basically dividing the moles of base by 2. So we're doing 0.00168 moles of NaOH multiplied by 1 mole of H2SO4 for every 2 mole of NaOH, so you're dividing by 2, or multiplying by half, it's the same idea. Cross NaOH out, and you get moles of H2SO4, so divide by 2. I get 0.000, there's 3 zeros there, 534. moles. And lastly, I do my concentration calculation. My C is equal to N over V. Which is equal to 0.0000534 moles over our volume, which was 0.0250 moles, or 250 liters, sorry. And we get 0.02136 molar. But how many sig figs do we need? It looks like we need it to be 3 sig figs based on our questions. So we'll have 0.0214 molar. And so the concentration of our H2SO4 is 0.0214 molar. We figured out the average volume using a titration reaction, or titration procedure, and then we did stoichiometry. So the key is remembering to balance your equation, remembering to find the average, and then doing all your sample problem, and then doing all your calculations using your proper ratio and your proper formulas. So now that we've done this problem together, when you practice your problems, you should have these similar steps or these same steps with your units, and you should be able to show a sketch of the titration reaction that you did, fully labeled, so better than mine. You could label the components. You can label this is our Erlenmeyer flask. You could label that this is your burette. You could also add that there's some indicator in here, so I'm going to put plus indicator. You don't want to put too much indicator because sometimes an indicator is acidic and it might lead us to estimate the concentration of our acid because it would require more base to neutralize it if you're adding more acid to begin with. So you usually want to do 2 or 3 drops of indicator, which should be sufficient to do the titration.